day, grade 8 students. Once again, welcome to my video tutorial. I am Ma'am LORNZ of Pililla National High School. Our topic today is about systems of linear equations in two variables. Target are the following. We have illustrates a system of linear equations in two variables. Second, graphs a system of linear equations in two variables. And categorizes when a given system of linear equations in two variables has graphs that are parallel, intersecting, and coinciding. A system of linear equation. A system of linear equations consists of two or more linear equations. This section focuses on only two equations at a time. The solution of a system of linear equations in two variables is any ordered pair that solves both of the linear equations. The standard form of a linear equation in two variables x and y is a sub 1x plus b sub 1y plus c sub 1 equals 0. A sub 2x plus b sub 2y plus c sub 2 equals 0, where a sub 1 plus b sub 1 plus c sub 1 equals 0, and a sub 1 plus b sub 1 plus c sub 1 equals 0 are real numbers. Systems are often signified by a single left-hand brace in place of the word and. A solution to a system of equations in two variables is a pair of numbers which satisfy all the conditions of the system. The graphs of linear equation ax plus by equals c is a line. Hence, two such equations can be graphed with two lines on a plane. The three possibilities for these two lines to be situated on a plane are as follows. Take a look of this figure. For figure 1, we have what we call intersecting lines. And the point of intersection is what we call the solution set. The graphs intersect at one point, and there is one solution. For our second figure, we have parallel lines. If the lines are parallel, there is no solution. Next is the graph which has infinitely many solutions. The graph is called coincide. Okay? So this figure is what we call coinciding line. In this case, we have many solutions. We're going to know if the point is a solution of the system. Let us take this example. Determine whether the given point is a solution of the following system. Point -3, 1. If we consider this as a solution set, let us see if this solution set is really a solution set. If the given system is x minus y equals -4, and 2x plus 10y equals 4, you have to plug the values into the equations. First equation, negative 3 minus 1 equals negative 4. That is true. So using the substitution method. For the second equation, we have 2 times negative 3 plus 10 times 1 equals negative 6 plus 10 equals 4. Again, this is true for the second equation. In that case, since the point negative 3, 1 produces a true statement in both equations, it is a solution. Let us have another example. Determine again whether the given point is a solution of the following system. The solution set is 4, 2. The system is 2x minus 5y equals negative 2 and 3x plus 4y equals 4. Plug the values into the equations. First equation, 2 times 4 minus 5 times 2 equals 8 minus 10 equals negative 2. Therefore, the point is true for the first equation. Now, for the second equation, we have 3 multiplied by 4 plus 4 times 2 equals 12 plus 8 equals 20. Now, in this case, 20 is not equal to 4. So, the statement is false. In this case, since the point 4, 2 produces a true statement in only one equation, it is not a solution. Why do we need to graph a solution or a system of linear equation? Since our chances of guessing the right coordinates to try for a solution are not that high, we'll be more successful if we try a different technique. Since a solution of a system of equation is also a solution common to both equations, it would also be a point common to the graphs of both equations. So, to find the solution of a system of two linear equations, graph the equations and see where the lines intersect. Algebraically, we can easily determine whether the graph of linear equation may be coincide or infinitely many solutions, parallel or no solution, perpendicular or intersecting or one solution if the following properties are satisfied. One has one solution and the lines are intersecting if m sub 1 times m sub 2 equals negative 1 and b sub 1 is not equal to b sub 2. M sub 1 is equal to m sub 2 and b sub 1 equals b sub 2 if it has no solution and the lines are parallel. Now, if it has infinitely many solutions and the lines are coinciding, if m sub 1 equals m sub 2, b sub 1 equals b sub 2, and c sub 1 equals c sub 2. The easiest way of graphing system of linear equations in two variables is by using the x and the y intercepts. Let us have the first example. Solve the following system of equation by graphing. We have a system x plus y equals 1 and x minus 2y equals negative 2. Recall that the intercepts are obtained by setting one variable to 0. For equation 1, we have x plus y is equal to 1. If x is 0, by substitution, 0 plus y equals 1, and simplifying further, y is equal to 1. Therefore, our first point for the first equation is 0, 1. Using the same equation, x plus y is equal to 1, or y is equal to 0. When y is equal to 0, x plus 0 equals 1. Therefore, the value of x is 1. Our second point for the first equation is 1, comma 0. So notice that we have the table. So the table there is x. If x is 0, y is 1. If x is, or if y is 0, x is 1. Now, the next step is to graph the 2 points. And graphing the first point, or point 1, which is 0, 1, we have this point. Next is to graph the second point, which is 1, 0. So, this is now the point 1, 0. And the next step is to connect the points using the line. Connecting the points, we have now the line or the graph of equation x plus y is equal to 1. Alright, let us have the second equation. So our second equation is x minus 2y equals negative 2. Again, we have to recall that we need to find the x and the y intercept. So if x is 0, we have negative 2y equals negative 2. Negative 2y divided by negative 2. And negative 2 divided by negative 2, y is 1. So therefore, if x is 0, y is 1. So our first point for the second equation is 0, 1. If y is 0, by substitution, x minus 2 times 0 equals negative 2. X minus 0 equals negative 2 and x is equal to negative 2. So meaning that our second point for this equation 2 is negative 2, 0. And take a look of our table. If x is 0, y is 1. If y is 0, x is negative 2. Now, we are now ready to graph the points. So, for our first point, we have 0, 1. For our second point, we have negative 2, 0. Connecting the 2 points using line, we have this figure. And this is now the graph of our equation 2, which is x minus 2y equals negative 2. Using one Cartesian plane for each system of linear equation, for the system of linear equation x plus y equals 1 and x minus 2y equals negative 2, okay, we have this figure. Okay, so we have the blue lines for equation 1, which is x plus y equals 1. And we have the green line for equation 2, which is x minus 2y equals negative 2. You will notice there is a point of intersection here. So this point of intersection has a coordinate of 0, 1. And this coordinate is called the solution set. So the solution set for the system x plus y equals 1 is and x minus 2y equals negative 2 is 0, 1. Which symbolizes solution set as SS. Furthermore, the lines intersect at one point, 0, 1. Let us check if the sum or if the ordered pair 0, 1 satisfies both equations in the system. For our first equation, which is x plus y equals 1, 0 plus 1 equals 1, 1 equals 1, the statement is true. Now, for our second equation, which is x minus 2y equals negative 2, by substitution, 0 minus 2 times 1 equals negative 2. Negative 2 is equal to negative 2. The statement is true. Thus, 0, 1 is the solution to the system of equations. The system is consistent system since The line is intersecting and it has only one solution. Let us consider our second example. So the given is x minus 3y equals negative 3 and negative 2x plus 6y equals negative 6. Recall that the intercepts are obtained by setting one variable to 0. For equation 1, x minus 3y equals negative 3. If x is 0, 0 minus 3y equals negative 3. 0 minus 3y equals negative 3. Dividing both sides by negative 3, which is the numerical coefficient of y, the first point now is equal to 0, 1. Using the same equation, x minus 3y equals negative 3. If y is equal to 0, x minus 3 times 0 equals negative 3. X minus 0 equals negative 3. X therefore is equal to negative 3. Therefore, we have now the second point, which is negative 3, 0. We are now ready to plot the points. In plotting the points, we have to consider also the table, wherein if x is 0, y is 1. If y is 0, x is negative 3. So the first point is 0, 1. And the second point is negative 3, 0. Connecting the points using a line, we have now the lines or the graph of x minus 3y equals negative 3. Moving forward, for our equation 2, negative 2x plus 6y equals negative 6. Again, recall that the intercepts are obtained by setting one variable to 0. So if x is 0, we have negative 2 times 0 plus 6y equals negative 6. 0 plus 6y equals negative 6. 6y is negative 6. Divide both sides by positive 6y, therefore is negative 1. So the first point for our second equation is 0, negative 1. Now for our second equation again, if y is 0, we have negative 2x plus 6 times 0 equals negative 6. Negative 2x plus 0 equals negative 6. Negative 2x equals negative 6. X is equal to 3. If point 2 or point 2 is equal to 3, 0. Now, we have again the table, which is 0, negative 1 and 3, 0. Now, we are now ready to graph the point or to plot the point, wherein we have point 1 as 0, negative 1, point 2 as 3, 0, and connecting the points, we have this line for the equation 2x or negative 2x plus 6y equals negative 6. If we are going to rewrite or to draw the point or to graph the point in one Cartesian plane, the figure looks like this. So you will notice that the two lines are parallel. If two lines are parallel, we may say that the lines or the equation has no solution. Okay, once again, take a look of the graph. The two lines are parallel. Since the lines do not intersect, there is no solution to the system. Thus, the system of the equation is inconsistent. Let us have our third example. So the given system is 2x minus 3y equals 6 and 4x minus 6y equals 12. Again, recall that the intercepts are obtained by setting one variable to 0. For equation 1, 2x minus 3y equals 6. If x is 0, 2 times 0 minus 3y equals 6. 0 minus 3y equals 6. Divide by negative 3, or divide both sides of an equation by negative 3. So y is negative 2. So our first point is 0, negative 2. Now, if y is 0, 2x minus 3 times 0 equals 6. 2x minus 0 equals 6. And 2x equals 6. X therefore is equal to 3. And the second point is 3, 0. Now, for our table, we have 0, negative 2. And 3, 0. Now, let us plot the points. In plotting the points, we have now 0, negative 2 for the first point. For the second point, we have 3, 0. Connect the points using a line. So this is now the graph of 2x minus 3y equals 6. Moving forward to our second equation, which is 4x minus 6y equals 12. If x is 0, 4 times 0 minus 6y equals 12. 0 minus 6y equals 12. Dividing both sides by negative 6, y is negative 2. The first point is 0, negative 2. Now, if y is 0, 4x minus 6 times 0 equals 12. 4x minus 0 equals 12. Dividing both sides by 4x is 3. And the second point is 3, 0. Now we have the table as 0, negative 2, 3, 0. Let us plot the points. In plotting the points, we have the first point as 0, negative 2. The second point as 3, 0. Then connecting the points using line, we have now the graph of the equation 4x minus 6y equals 12. We are going to graph the system in one Cartesian plane. The figure will look like this. Notice that the intercepts of the two equations are exactly the same. This means that both equations represent the same line. Since the two lines are identical or coinciding, each point on the line is a solution to the system. A system has an infinite number of solutions. Thus, the system of the equation is independent. In order for you to understand better the lesson, you have to remember the following concepts. X-intercept is the axis of a point where the graph passes through the x-axis. It has coordinates of x, 0. Y-intercept, the ordinate of a point where the graph passes through the y-axis. It has coordinates of 0, y. And to graph a linear equation using the intercept, you have to find the x-intercept, let y equal 0, and solve for x. Second, find the y-intercept, let x equal 0, and solve for y. 3. Represent the intercept by coordinates. Plot the points given the coordinates, and connect the points to form the graph. Once again, this is Ma'am LORNZ of Pililla National High School saying thank you very much for watching.